Every card flip, every depth effect you've ever shipped, it was probably faked. Layered box shadows, pre-rendered PNG images, JavaScript recalculating geometry on every single frame. And this whole time, CSS had real GPU-native 3D built right in. Most developers just never learned to use it properly. Before hardware-accelerated CSS, creating depth meant stacking box shadows 10 layers deep, exporting 3D objects as PNG files, or writing JavaScript that recalculated positions on every animation frame. All of it was expensive, and it always looked like what it was, a trick. Today's browsers delegate 3D CSS transforms directly to the GPU, the same chip that renders video games. That means hardware-accelerated 3D at 60 FPS, no JavaScript, no paint cycles, no layout recalculation. The browser just hands it off and gets out of the way. The entire CSS 3D system rests on exactly 3 properties. Perspective, which sets the viewing distance. Transform style preserve 3D, which keeps nested elements in actual 3D space. And backface visibility, which controls what you see when an element rotates away from you. All 3 are non-negotiable. Perspective is the most misunderstood property in CSS 3D. It defines the distance between the viewer and the z=0 plane, essentially how far you're standing from the object. Set it too low, like 200 pixels, and everything warps dramatically. Around 800 to 1200 pixels feels true to life. Here's the trap that catches almost everyone. By default, the browser takes any children of a transformed element and flattens them into a 2D plane. Transform style. Preserve 3D overrides that behavior. It forces child elements to retain their own position in real 3D space. Without this one property, nothing you do will work. When a card rotates past 90 degrees, you're looking at its reverse. Without backface visibility hidden, the front content bleeds through, mirrored, and inverted. It's the property that separates a clean flip card from one that looks completely broken. It's also the one developers forget most often. Start with the scene container. This div does not transform at all, it just sets the stage. Give it the perspective value, a fixed width, and an aspect ratio so the geometry stays proportional at every viewport size. This is the single vanishing point that all children will be rendered relative to. The inner wrapper is where all the action lives. On hover, it rotates 180 degrees, and preserve 3D keeps both faces floating in the same 3D space. The cubic-bezier curve, 0.23, 1, 0.32, 1 specifically, starts fast and overshoots slightly before settling. That overshoot is what makes it feel physical instead of mechanical. Both faces are position absolute, stacked in the exact same physical space. The back face starts already rotated 180 degrees, so when the parent wrapper flips, it arrives perfectly face forward. And both faces hide their own backs with backface visibility hidden. That 3-part setup is the complete flip card mechanic. The entire flip is triggered by one hover rule, not a JavaScript click listener, not a state toggle in React, just a CSS selector computing a GPU-native 180-degree rotation. The easing curve handles the physical feel. The browser handles the rest. For complex 3D components, you want the browser to commit the element to its own GPU layer before the animation ever starts. Either translateZ 0 or will change transform achieves this. It's a hint to the browser. Pre-promote this element so there's no expensive recalculation happening in the middle of the animation itself. Here's the most common silent killer in CSS 3D apply overflow hidden to a parent that wraps your 3D element. The browser can't maintain 3D compositing inside a clipped boundary. The entire 3D context collapses, everything flattens, and there is no error message, it just breaks with zero explanation. When you put perspective on the parent container, every child shares one vanishing point, they feel like they belong to the same physical world. But if you apply the perspective function directly inside each child's own transform, every element gets its own independent vanishing point. Same property, completely different spatial result. The placement is the decision. One last detail that's easy to overlook. Put aspect ratio on the scene container. Without it, the card stretches or squishes as the viewport changes and the 3D geometry breaks. A 2:3 ratio is a solid starting point for anything card-shaped. It keeps your 3D proportions locked regardless of screen size. That's the complete component, pure CSS, no JavaScript. Smooth, GPU-accelerated 60 FPS on any modern browser. 3 properties building real 3D space, and the entire user interaction is one hover rule. That's what CSS has always been capable of. Most developers just never went this deep. If this clicked for you, like the video and subscribe. Stone covers CSS, React, TypeScript, Node, and modern web engineering at exactly this depth every single week. And seriously, go build the flip card. The moment you see it work in your own browser is the moment CSS 3D stops feeling like magic and starts feeling like a tool.